In this module, we're going to take a look at the typing rules that Java applies to its variables, the casting mechanism that we can use to override those rules should we need to, and we'll take a look at the arithmetic and the comparison operators that Java provides. Again, let's start by creating a new project. Again, a Java application, and we will call this one Operators. The first thing we'll do is to declare some variables that we can use. So we'll have a short, an int, and a long. And then, by way of example, we will demonstrate that we can take a simple variable of a short type and we can assign that into a wider variable. So a short, remember, is 16 bits, and an integer, an int, is 32 bits, and that means that an int is considered wide enough to receive a short, and the assignment is considered compatible. But next, we notice that if we attempt to assign a long value, that's a 64-bit wide value, into a short variable, that doesn't fit. Although we might know that the long value is perhaps small enough to fit into a short variable, in this case it actually isn't, the compiler will refuse to allow that because it can't be sure. So we can't say a short equals a long. And also, if we do arithmetic, here using the addition operator, the plus, if we try to add a long and a short, the result will always be at least as wide as the widest value involved in the operation. So here you'll see possible loss of precision, required short, found long. In other words, it's complaining that this expression has a long type, which is too big to be assigned into this value. So we can't do that either. What we can do, however, is to overrule the compiler and say, I don't care if this loses value, either because we don't care and we're only looking for the low order bits of the result, or because we know that it won't lose value. In this case, we will lose value. If we force this assignment from our long into our short, then what we will get is just the low order bits stored in that short value. So here we're saying, take the long value, cast it, that's what this is called, a cast operator, to being a short. And really that means just chop off the low order 16 bits. So that would be the hexadecimal value BABE, and it would lose the CAFE part of it. It's worth noticing that if we print out the result of this operation, here we'll print out the value of the short and the value of the long. If this assignment worked properly, we would expect the two values to be the same. But in fact, what we will see when we run this, if we build the project and run it, you will see that the output values are different. CAFEBABE in hexadecimal turns out to be -889275714, and that's the value of A long, but the value of A short is chopped off 16 bits worth from the low order of that. So of course we get a completely different value, and that's the kind of thing that the compiler is worried about and why it doesn't want us to make this assignment directly. Java also provides a full set of arithmetic operators. So as you would expect, we can add, we can subtract, we can multiply, we can divide. So here we take the two decimal values 64 and 64 and add them with the plus operator. Then we can subtract with the minus operator. We can multiply with the asterisk, the times operator, and divide with the division operator, which is a /. Those ones are probably obvious. We also have the remainder or modulus operator. So what we'll see when we run this version is 64 plus 64 should give us 128. Subtract 127 from that, we should end up with 1. Multiply by 100 should give us 100. Divide by 10 should give us 10. And mod 4 will say what is the remainder of 10 divided by 4. And that, of course, will be 2, remainder 2. So if we run that, save the file and run it, we should see 128 from 64 plus 64, the 1, the 100, the 10, and the 2. Java also provides increment and decrement operators. These are actually borrowed from the old C language, still very popular. Here we see that there are two forms of this. We can put ++ immediately after a variable. What that does is to say the value of this immediate expression is the value an integer, but after we've used it, increment it by 1. So what we'll see is that an integer is currently 2, and it will actually still be 2 when it prints out. But if we print it out again immediately afterwards, we'll see that the value is 3. The other version of this, and we can do this with ++ and -, we can put it afterwards, in which case we get the post-increment or post-decrement effect, or we can put it before, in which case we get the pre-increment or pre-decrement effect. So in this case, we'll expect to see this value will print out the same value of an integer, i.e. 2, and then increment it to 3, so this one will print out 3. And then the pre-decrement will reduce the value from 3 to 2 and print it out immediately. So if we run this version of it, we should see that the post-increment prints out the original value, but then results in it increasing. The pre-decrement decrements it by 1 before it makes the value available to the rest of the expression. So remember, we have ++ and -, either of which can be in advance of the expression, like here, or after the expression, as here. Something else that Java does, which again is derived from its heritage with the C programming language, is that assignment itself is an operator and has value. So here the assignment an integer equals 99 actually is an expression with the value 99. So if we print this one, you'll see that assignment value is 99. So not only does this equals operator assign the value from the right side to the left side, it also results in an expression which takes the value that was assigned. While on the subject of things inherited from the C programming language, we also have assignment operators. Here we see an integer plus equals 99. What that does is to take the value of an integer and add 99 to it. There's a couple of things that are interesting about this. If on the left-hand side we have a more complex expression, perhaps something involving arrays, that expression is only evaluated once, instead of being evaluated on the left side and on the right side. This is roughly equivalent to an integer equals an integer plus 99. The other thing that is interesting is that notice here an integer plus equals a long is effectively equivalent to an integer equals an integer plus a long. But remember when we talked before about casts, we said that if we take an operation like this, then the size of the expression will be the size of the largest of those operands. What that means is that if this was literally an integer equals an integer plus a long, then this would result in a long value that would not be assignable to an integer. But by using the assignment operator like this, the plus equals operation, what that does is to create a situation that automatically casts for us. So it becomes more like an integer equals an integer plus a long cast to an integer. Finally, for this module, Java provides a set of comparison operators. We have the greater than operator, less than, greater than or equal to, less than or equal to, and not equal to. It's important to get the order in greater than equal or less than or equal to correct. You must put the greater than or less than symbol first and the equal sign second. Each of these returns a Boolean type, so 100 greater than 99 will produce the value true, 100 less than 99 will produce the value false. Similarly, for the rest of these, we'll get trues and falses according to the logic of what we have described. So if we run this one, you'll see 100 greater than 99 is true. And notice it really does evaluate to the Boolean value true. Similarly, false, true for greater than or equal, false for less than or equal, false for equal to, and true for not equal to. Recognize that the two equals symbol provides comparison, where the single equals provides an assignment. That's an important difference. So to recap, in this module we've looked at the assignment and the fact that assignment has value. We've looked at assignment and the typing rules and the fact that we cannot assign wider types into narrower types. We've looked at how to cast to overcome that rule if we need to. We've looked at the basic operators for arithmetic: add, subtract, multiply, divide, and modulus. We've looked at the increment and decrement operators, and we have looked at the assignment operators, plus, equals, and we have looked at the comparison operators.